Streamlining serverless deployments on AWS with Terraform and GitHub Actions. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Serverless architecture has revolutionized how applications are built and deployed, offering scalability, reduced operational costs, and faster time to market. As a leading cloud provider, AWS provides a comprehensive service suite enabling developers to build, deploy, and manage serverless applications. This podcast will guide you through deploying a serverless application on AWS using Terraform for infrastructure as code and GitHub Actions for continuous integration and deployment. C/CD. Prerequisites for getting started. Before diving into the implementation, it's essential to ensure you have the necessary prerequisites. AWS account. An active AWS account is required to deploy and manage resources. GitHub account. To store your code and automate deployments, you'll need a GitHub account. Essential knowledge. Familiarity with AWS services, Terraform, and C/CD concepts will be helpful. Local development environment. Ensure your local machine has the necessary tools installed, including AWS CLI, Terraform, and a text editor. Required tools and services. To build and deploy your serverless application, you'll need the following tools and services. AWS services: Lambda, API Gateway, DynamoDB, S3, IAM, Route 53, and AWS Amplify. Terraform. This is for defining and managing your infrastructure as code. GitHub Actions. For automating C/CD workflows. AWS CLI. To interact with AWS services from the command line. Setting up your development environment. Install Terraform. Download and install Terraform from the official Terraform website. Install AWS CLI. Follow the instructions on the AWS CLI installation guide. Configure AWS CLI. Set up your AWS CLI with your AWS credentials using the command AWS configure. Overview of the serverless application architecture. Understanding AWS services involved. AWS Lambda executes backend logic in response to HTTP requests via API Gateway or events from other services. API Gateway. This function acts as a front door for your application, managing API requests and routing them to appropriate Lambda functions. DynamoDB. A fast and flexible NoSQL database for storing application data. S3. Stores static assets like images, CSS, and JavaScript files. Route 53. Provides domain management and DNS routing. AWS Amplify. Simplifies front-end deployment, hosting, and integration with back-end services. High-level components and their roles. Front-end. Built using a JavaScript framework and hosted on AWS Amplify, with domain management via Route 53. Back-end. Consists of Lambda functions triggered by API Gateway, with data persistence in DynamoDB and static asset storage in S3. Infrastructure. Defined using Terraform to ensure reproducibility and version control. Detailed implementation steps. Initial setup and configuration. Creating an AWS IAM user. Log in to the AWS Management Console. Navigate to IAM > users > add user. Create a user with programmatic access and attach the necessary policies for deploying resources. Configuring the AWS command line interface, CLI. After creating the IAM user, configure the AWS CLI with the following command. AWS configure. Enter your AWS access key, secret key, region, and output format. Infrastructure as code with Terraform. Defining IAM policies and roles. Use Terraform to define IAM policies and roles required for your serverless application. Here's an example. Resource AWS_EAM_role lambda_execution_role. Name equals lambda_execution_role. Assume_role_policy equals JSON encode. Version equals October 17, 2012. Statement equals. Effect equals allow. Principal equals. Service equals lambda.amazonoz.com. Action equals STS assume role. Establishing a code repository with AWS Code Commit. If you prefer AWS hosted repositories, create a code commit repository using Terraform or the AWS console. Building the front end with AWS Amplify and Route 53. Hosting the front-end application. Use AWS Amplify to host your front-end application. You can deploy your code directly from GitHub, and Amplify will handle the build and deployment processes. Domain management and DNS configuration. Configure your custom domain in Route 53 and link it to your Amplify app for seamless access. Backend implementation using Lambda, API Gateway, DynamoDB, and S3. Developing Lambda functions. Write your backend logic in Lambda functions triggered by API Gateway. Here's a basic Node.js Lambda function. Exports.handler equals async, event, equals greater than. Return. Status code, 200. Body, JSON.stringify hello from Lambda. Semicolon. Semicolon. Setting up API endpoints. Use API Gateway to create and configure REST API endpoints that trigger your Lambda functions. Database design with DynamoDB. Design your DynamoDB tables to store application data efficiently. Use Terraform to automate the creation of these tables, storing static assets in S3 buckets. Create an S3 bucket for storing and serving static assets, with public access settings as required. Automating deployment with GitHub Actions. Setting up continuous integration and continuous deployment. C/CD create a GitHub Actions workflow file, .github/workflows/deploy.yml, to automate the deployment process. Here's an example. Name, deploy. On, push. Branches. Main. Jobs, deploy. Runs on, Ubuntu latest. Steps. Uses, actions/checkout at v2. Name, setup Terraform. Uses, HashiCorp/setup Terraform at v1. Name, Terraform init. Run, Terraform init. Name, Terraform apply. Run, Terraform apply auto approve. Workflow automation for code changes. With GitHub Actions, every push to the main branch will trigger the deployment workflow, ensuring your application is always up to date. Best practices and considerations. Security measures. Implementing least privilege access control. Ensure IAM roles and policies follow the principle of least privilege, granting only necessary permissions. Ensuring secure communication. Use HTTPS for all API gateway endpoints and enforce encryption for data at rest and in transit. Cost management strategies. Monitoring and optimizing costs. Regularly review your AWS bills and optimize resource usage. Leveraging reserved instances and spot instances. Use these options for predictable workloads to reduce costs. Monitoring and logging. Utilizing AWS CloudWatch for observability. Set up CloudWatch logs and metrics to monitor application performance and detect issues. Log analysis and alerting. Implement log analysis and alerting to stay informed about application health. Testing and validation. Infrastructure testing with Terraform. Use Terraform's plan and apply commands to validate your infrastructure changes. Continuous testing and quality assurance. Integrate unit and end-to-end tests into your C/CD pipeline for ongoing validation. Conclusion and further learning. Deploying serverless applications on AWS with Terraform and GitHub Actions allows for a seamless and automated workflow, ensuring your infrastructure is always in sync with your application code. You can build a robust, scalable, cost-effective serverless application by following the best practices and leveraging the tools and services mentioned. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.